All right, we should be recording. Great. Okay. Hi everybody. Welcome to day 2 of the R Bootcamp, which is about data visualization. Originally, a Biostat PhD student was going to take over today, but unfortunately they fell ill yesterday, so I will be teaching today. Tomorrow we should have Eleanor to teach the day 3 on high performance computing and data wrangling. So, welcome back. How many people do we have? Whoops, sorry. We have people online? Yeah, we've got 22 people online. Great. Okay, so just like before, I can't see you if you're online, so please, feel free to interrupt or send me a message, chat message. I will try to keep to the actual time limit today. I apologize for running late yesterday. There's a lot of, I think, really important foundational stuff that I wanted to get through. But today, hopefully a little bit lighter. Okay. Hi to those of you here in person. Glad to see you. Let's talk about data visualization. So I'm going to sort of be jumping back and forth between RStudio here and some slides, which I'm just going to point out are from my course, PM 566. PM is preventive medicine. It's the old name for public health, population and public health sciences. But anyway, PM 566 is Introduction to Health Data Science. Data science, I think, being the operative words here. This is the course that I teach in the fall. And, we had a whole lecture on data visualization. I'm reusing some of that material because obviously that's how I teach data visualization. So that's my plug for PM 566. Okay, so just as an example, I want to do some of the really basic things that we did yesterday, all of which used the iris dataset. So I'm just going to pull up the iris dataset the same way I did before, and you'll notice that adds it to our environment. And let's remember quickly what this data set looks like. If we click on it, we open up this spreadsheet view, and we've got 4 numerical variables and 1 categorical. Kind of the most basic and honestly most important plotting functions that you will ever use is hist, which is short for histogram. And this is just a way to look at the distribution of a variable. When you're doing exploratory data analysis, especially for a data set that you aren't deeply familiar with, you should really start with looking at the general distribution of every variable. If you can do that, do that. Like if it's less than 100 variables, just look at the marginal distribution of every single one of them. So here, we would do that. Hist obviously takes a numeric vector of values. So we're just going to pull out one of the columns that we're interested in, say sepal length. And again, notice I'm using the tab completion. That way I don't have to worry about capitalization, automatically gets those things right. And if I run that, it creates a nice little histogram for me. You might not particularly like this histogram. It's got a lot of ugly elements to it. I really don't like that it shows, iris $ sepal.length in both the title and the x-axis, but it's a quick and easy way to look at this distribution. We can do the same thing with, say, sepal width, petal length, and petal width. And we notice that the petal distributions look pretty different, right? These are pretty bimodal. There's a group on the left and then a group on the right. Same with petal length. Whereas sepal width is a relatively, it's definitely a unimodal distribution. And sepal length is a little bit hard to tell, but probably also unimodal. One thing I will point out is that the number of bins is chosen automatically by an internal algorithm, but you don't have to just accept it. You can change the number of bins by setting breaks or number of breaks between bins equal to whatever number you want. So 20 or 20 to 30 is a good number for me to just sort of get the general shape of the distribution. This might have been a little bit too far because, this might have been a few too many breaks because now we see that we've got this weird up and down pattern in the frequency. And sometimes it doesn't make a difference. I don't know. There's some other weird internal defaults going on that are messing with this, but you can also obviously go way too far and end up with something not very meaningful. Okay. Sorry. For the people online, there's like noise coming from the room directly behind me, and I'm finding it distracting right now. The other basic plotting function that everybody should know is just called plot. And the plot function is capable of doing a lot of things. It's best at doing scatter plots and line graphs. If you don't tell it what to do, it'll just do a scatter plot. So for example, if we wanted to look at sepal length versus sepal width, we'd provide those two vectors, sepal length and sepal width, and plot them, and it would create a nice little scatter plot for us. Again, I don't love that we've got whatever. This is not exactly a publication quality graphic, but it's really helpful for exploratory data analysis. It was a quick, one line of code, didn't have to think about it too much, and we get to look at the data and see, this is the distribution. This is the joint distribution of these two variables. We saw we had that sort of bimodal distribution when it came to the petal length and width. So let's just look at what those look like. And there it is. We see two pretty distinct groups. Not surprising, right? Given the histograms that we saw, both had a smaller group on the left and then a wider group on the right. So both of these variables, it's sort of reassuring to see that the smaller petal length corresponds to the smaller petal width rather than being sort of randomly distributed. You can change the color with the color function. So if I want these to be red, I can do that. And there are ways to change the type of marker that is used. So if I want full dots rather than empty dots, you can say PCH equals 16. PCH is the point type. And there are a lot of different options for that I can get into in a minute. Yeah, that's what I want to. Oh, and then you can also set the type. So if I wanted to do a line graph, this data is not particularly suitable to a line graph, but we'll do it anyway just to see what it looks like. This is going to be a mess. But remember, this is our scatter plot of sepal length versus sepal width. If I say type equals L for lines, it'll draw a weird scribble like this, but just trust me when I say that that line is connecting all of the dots in this, and it's just purely based on their order within my data set. And so, it's basically just going down the rows of this data set and connecting the first to the second to the third to the fourth. If you had, say, time series data where your data was ordered from time point 1, time point 2, time point 3, then this would make a lot more sense and you'd see sort of a more clear pattern. And same as before. We can change the color if we want. The built-in colors are okay, but not great. So 2 is red, 3 is green, 4 is blue. That's as far as I remember. After that, maybe orange. Nope, like a teal, I guess. They only go up to 9 before they cycle back around. If I do 10, I think we're back at red. Yeah. There's a whole world of packages out there that provide nice colors. So the built-in colors are not the best, but they get the job done for like quick exploratory visualizations. If you need more than 9 distinct colors, then you're probably in the territory of wanting to go find some package that provides nice colors. But the default is always color equals 1, which is black. The nice thing about the base plotting functions is that you can add elements. So let's say I plotted these. The plot function sets up a default plotting window, right? It sets up a window based on sort of the maximum and minimum values for both your X and your Y variable. But once you've got that plotting window, you can add elements to it. So let's say I had already plotted sepal length and sepal width, but then realized I wanted to add some additional element to it. Let's say I wanted to add a line, a 45-degree line, right, where X equals Y. That's a common element that people want to add on their plots. You can easily do that. I prefer, so the best way to do it is with the AB line function, which allows you to add a line based on an intercept and a slope. So if I just say AB line 0, 1, that means the y-intercept is 0 and the slope is 1. That's going to give me that 45-degree reference line. You can see it's sort of way off in the corner here because the sepal length tends to be greater than the sepal width. If you want to add arbitrary lines, the same way that we can plot arbitrary lines, the function is just called lines. And the same way that you plot based on X and Y variables, you can add lines based on X and Y variables. So if I just do sepal length and sepal width, we'll see that it reproduces that weird scribble from before that connects all the dots. And then the corollary of lines is points. And this is the way to add points to a plot. So I'm going to say color equals 2, and this will add red dots over top of our existing black dots. And there they are. Fill it in so it's a bit more clear. So this is not like a plot that you would ever want to make in practice, but it's a good demonstration of the different capabilities of basic plotting. Is it possible to change the origin to 0? Origin to 0. Okay, I think I know what you're asking.
Sorry,
like-
I just meant like zeros. Yeah, like so that you see it, so that X start the, I don't know how to say it properly, like it starts at 0, 0 in the at the origin of the XY.
So basically the x-axis extends all the way to 0 on the left.
Yes,
and
yes.
the y-axis extends all the way to 0 on the
Yes,
bottom.
yes.
Yeah.
Mhm.
It's possible. You have to sort of massage it a little bit. So The way that I would do that is actually a little bit weird. I would use the plot function to set up the plotting window and then add the points function to add the points. So in this case, we're interested in, so I'm using C for concatenate, 0, and then max for the maximum of sepal length. And that's sort of the minimum value and the maximum value that I want for my plotting window. And then similarly, just copy that. But we want sepal width for the y-axis. And then I'm going to say color equals white so that it doesn't even show up. And what that's going to do is it's going to set up the plotting window with the coordinates that you wanted. So it goes from 0 to the maximum value of sepal length and sepal width. And then we can actually add the points the way that we did before with this points function. And so there's that plot that's sort of
Okay, cool.
direction.
Awesome. Thank you. Thank
Yep.
you.
A really handy function also for doing this type of thing is range, which tells you the minimum and maximum of a particular numeric vector. So the range of sepal length is from 4.3 to 7.9. And actually here we can, this would be a better plot anyway for showing that reference line that I mentioned before. AB line can also add horizontal and vertical lines. So if we wanted a horizontal line at, say, y equals 1, we can say h for horizontal equals 1. And similarly, AB line v for vertical at, say, 4, we'll create a vertical line at 4. All right. One other thing that I mentioned yesterday is that, okay, so we talked about factor variables. The species variable is a factor, and you can color by a factor variable, and it'll basically treat these levels as being 1, 2, 3. And so remember I showed earlier that the colors for 1, 2, 3 are black, red, green. And so if we were to plot this sepal length versus sepal width and say color equals iris dollar species, because it's a factor variable, it'll treat those factors as 1, 2, 3, and we'll actually get a plot that has black, red, and green points. And then one other useful type of plot, I mentioned the other day the table function. So table is a really good way of counting up the different elements of a categorical variable. So if we say table iris dollar species, it tells us that we've got 50 of each, Setosa, versicolor, and virginica. And if you're doing exploratory data analysis, trying to get familiar with your data, I think the best visualization for this type of data is a bar plot, and the function for that is just called bar plot. And so you can feed this table directly into a bar plot, and it'll make the bars. Not the most interesting bar plot because all of the values are equal to 50, but you know, it's a good demonstration of the capabilities. You can also set the color if you want the colors to match what we had before. Yeah, there's a lot you can do with bar plot, actually. If you give bar plot a matrix of values rather than just a vector, it can create stacked bar plots, or alternatively, it can create side-by-side bar plots. So bar plot has a lot of functionality. Um,
Oh, excuse me.
yeah,
Could you explain why the colors are coded 1, 2, 3 again?
it's just a default in R for when you want different colors. They've only got, 8 or 9 built-in colors.
Okay.
If I say plot 1 to 10, 1 to 10, color equals 1 to 10, we can see all of them.
Oh,
See?
so
Uh,
no matter what data set you're working with, you can just use these default colors.
yeah, yeah. And like I said, they're not great, but sometimes you just want a quick and dirty exploratory plot, and you need different colors in order to be able to distinguish different groups. And so these are there for your convenience. So you can just say color equals 2 rather than going to all the trouble of trying to find the perfect color for something.
Sure, thanks.
Yeah. That said, if you do feel like finding the perfect color for something, there are a lot more built-in options. They're just not mapped to integer values. So actually, if I call the colors function, it gives this really long list of different colors, all of which are available to you. And one of the really nice features that RStudio has recently added is that if you type one of these colors, so I'm going to type Misty Rose because that's what I'm looking at, it'll automatically be highlighted in that color. There's Misty Rose, there's Navy Blue, there's Moccasin. There's all these different built-in colors that you can use for when you do want to get it just right for like a publication quality graphic.
Thanks so much.
Mhm. Okay. One other plot type that I want to mention is a box plot. I find box plots to be extremely useful, especially when you're working with large amounts of data. A box plot is basically a 5-number summary of a particular data set. So for example, if I did box plot iris dollar equal length, we would get this. And so this is even an even more rough summary of the distribution of that variable. So it's showing us slightly less information than a histogram, right? When we saw the histogram, we sort of saw a little bit more of the overall pattern. Here we just have the median, the 25th percentile and the 75th percentile, and then the maximum and minimum. And if there were any outliers, they would show up as additional dots, sort of above and below these bottom fences. The nice thing about box plots is that you can do lots of variables at once. So if I do box plot, iris, and I'm just going to do -5 because our 5th column is not numeric. It's only the first 4 that are numeric. This will give me a box plot for all of those variables, all 4 of those variables. I'm just going to make it a little bit bigger so that all the names show up. And there we go. And so you can see with the sepal width, this is what happens when you've got outliers. And otherwise, it just shows you sort of the rough distribution of all 4 of these variables. Um, Box plots and bar plots, I should also mention, they can be added to an existing plot. So before plot can do points and lines, and the way that you add points and lines to an existing plot is with those functions, points or lines. But box plot it does both. Box plot is capable of creating its own frame, or it can be added to an existing frame. And so you do that by saying add equals true. Let's just say color equals 2 so that we know we're adding something. I've added those red box plots over top of the gray. If I click the previous plot, we can see it's a completely different one. It's not, I didn't create a new plot. I just added red over top of the gray on an existing plot by setting this add equals true. And you can do the same with bar plots. Okay. So all of the functions that I've talked about so far are they're the base R plotting functions, meaning if you've only installed R, and I guess RStudio, you have access to these plotting functions. For me, that's good enough. Like, I know how to manipulate all the different elements of a plot like this to make it publication ready. But a lot of people, including a lot of, very advanced R users, hate this. They refuse to plot anything this way. And I don't get it, but I would be remiss if I did not teach you about ggplot. So I'm going to switch over to my slides now because I don't have the skills to code ggplot on the fly. ggplot2 is a package. It's a very well-established package. It's on CRAN. You can install it the way that you install any CRAN package with install.packages ggplot2. That needs to be in quotes. Oh, you can use single quotes or double quotes here. I often use single quotes just because that way I don't have to press shift. But if you haven't installed the ggplot2 package, that's how you would do it. And then when you want to load that package, okay, so you need to install it, and then you can load it, library ggplot2. That loads the package into your current R session. And ggplot2 is the graphics package. GG stands for grammar of graphics. It's what a lot of people use. I would say the majority of R users use ggplot2 for their graphics. It's supposedly based on the principle of adding layers, but I don't fully understand how. But the one thing to know is that it always starts with the data. It always starts from a specific data set, which is usually, they generally encourage you to encode that in a data frame. So that's actually kind of nice because it allows you to avoid things like this, where I have to say iris dollar sepal length, iris dollar sepal width, just to pull out those two variables. Instead, the whole plotting mechanism starts from a data set. So they only have to say iris once and then say, this is the data set we're using. Now plot sepal length versus sepal width. You start a ggplot with the ggplot function, and then things get weird. You give it so the first argument is the data set, right? Say data equals iris, and that will start a ggplot based on the iris data set. But you add layers with the plus sign, and this is very non-standard usage. The only place you'll see a plus sign used in this way is when you're using ggplot. I've never seen it used this way anywhere else. It always means addition, except when it comes to ggplot. And so the plus in this context is used to add layers. So here we might be using a geom, which is short for geometry, and that tells it what type of thing you want to do, a point or a line or a bar plot or a box plot or whatever. This takes a mapping argument, which is always paired with the AES function, which is short for aesthetic. Why all these things are necessary, I don't understand, but basically the aesthetic is where you set the X and Y variables. Okay. Here's an example that uses a different data set. This is weather data. And so it's just observations of weather from various US weather stations. And basically, here's the scatter plot you would get using plot, right? This is the base plot version. And like I said before, it's kind of ugly. The axis labels have the $ in them. The text here is vertical rather than horizontal. The points are hollow rather than filled in. Doing the same thing with ggplot, this is the plot you get. And it's a little bit better. I don't love everything about it, but like it's a better scatter plot for the most part. The points are filled in, which for this particular data set makes it a little bit harder to see what's going on in the middle because you can't really see the density of points in the middle. But the axis labels are just temp and RH, which in this case is short for relative humidity. These are the names of the variables. We plotted the same thing here, but we had to have this met average underscore whatever $RH $temp. Here it's just the names of the variables that were plotted. And the y-axis text is horizontal rather than vertical. And we've got these little reference grid lines in the background that sort of allow you to easily track particular values that you might be interested in. So it took all this code, right? It took 2 lines of code to make this plot, but I do think it's a slightly better plot. We can see a similar thing. I'm just going to copy this over to show that it can be done once you've got some existing code. We're going to use the iris data set and say x equals sepal.length. Notice I've still got tab completion because it's smart enough to know that it needs to look at the iris data set. And sepal.width. And if I plot that, we get an error. We get error, ggplot, could not find function ggplot. That's because I never actually loaded the package. If I run that line of code and then plot it, we're good. And so there's the sepal length and sepal width plot in ggplot style.
So do you need to write library parentheses ggplot every time you, like every new day when you start?
Yeah. You only need to do it once per R session.
Okay.
So if I created another plot down here and I did different things, like I wouldn't need to reload the package. It's already there. But yes, once per R session, you need
Okay.
to do it. And so what a lot of people will do is just put that up at the very top. And any other libraries that they are going to want throughout the course of their session, they'll just load them at the top of the script and then not worry about it. Since we're here, let's do petal length, petal width. There's that plot. Okay, so this is the basic scatter plot. As we've seen before, you can color by certain things. This is one of those that ggplot actually does a really good job of simplifying for you. If you choose another variable to color by, all you have to do is specify that variable and it'll create a legend for you. Creating legends in baseplot is annoying. So the fact that ggplot handles this automatically is actually very useful. Is it under aesthetic? Yes. Color. I'm just going to put this on a new line so that you can all see it, but you don't have to. You can just have it be a continuation of the previous line. Color equals species. Go. Great. And so it created this petal length versus petal width plot, this time colored by species with a super handy built-in legend. I will point out that the default colors are not the same. So notice we've got red, green, blue rather than black, red, green. I think it just skips over black when you've got some sort of categorical coloring going on, but I'm not entirely sure how ggplot chooses its default colors. And I'm also pretty sure these are not the same shades of red, green, and blue that you get with baseplot. So, you know, somebody probably decided that these were better for visualization. Another helpful thing is the transparency. You can do this in baseplot as well, but alpha is commonly used as the name for a transparency variable. So if you set alpha equals 1, that just means normal, fully opaque plotting. But if we, I'm going to go back to the other one because there's a little bit more. Oh, no, there really wasn't. Just say alpha equals 0.25. And notice all of my points now have a little bit of transparency to them. 6.5. Then there's a little bit less transparency. I can just say alpha equals 1. And we're basically back at, oh, no, there's still some transparency there. It's like the inside of the point is transparent, but the outside isn't. All right. Well, I don't really know how they're doing this. It's some weird choices. But this is how you add some transparency to your plot, which can be very helpful in cases like this, where you've got a massive amount of overplotting. And so it's really hard to see where is the maximum density of points. It's very helpful in those cases to add some transparency. It's even helpful in cases like this where we've got points that overlap perfectly, right? So you can kind of tell there's multiple points here, but there's only one at these other locations. And so adding transparency to plots is often a good idea because it prevents overplotting. Just as with base plot, you can choose different shapes for your points. So here there's circles and triangles. I don't think that looks good, but you can do it if you want. Yeah, here just manually setting the color to blue. Here's sort of a quick rundown of the different types of things you can do just within that AES function that you need to use for the mapping. X and Y obviously correspond to the X and Y positions. The shape is relevant if you're doing a scatter plot. It's the shape of the points. The color is relevant no matter what. That's the color of the plotting element. Fill for things that are polygons like a box plot or a bar plot. That's the fill color. So you can have different border color versus fill color. Size is particularly relevant for scatter plots. If you've got a really sparse scatter plot and you want every point to be a little bit bigger, you can increase the size. Similarly, if you've got way too many points and you want them all to be smaller, you can decrease the size. Alpha, as we said, is the transparency, and line type is the type of line. So if instead of a solid line, you wanted a dashed line or something like that, you can change the line type. All of these things are also possible in base plot, and in a lot of cases, they're simpler. You don't need to specify x equals. You can just leave it unnamed, give the first argument as x, give the second argument as y. But some of these names make way less sense. So like PCH is the argument that you have to set in order to change the shape of a point, whereas I think shape is a much more intuitive name for that. Call is the color, fill is the fill color. CEX, which is something about expansion, is the size parameter. And in base plot, there's actually no way to set the transparency, but there's a commonly used graphics package called scales that has an alpha parameter that allows you to add transparency to any existing color. And then LTY for line type is the argument for that. Yeah, I'm not going to focus. I'm going to focus more on ggplot because we've switched over to the ggplot part of this lecture. Okay. Any questions at this point? We've covered a lot so far. The biggest thing that I want you to remember, and like the first primary difference between the base plot and the ggplot, is that ggplot always starts with a data set. It always starts with some sort of rectangular matrix of data, which is usually a data frame, a data dot frame. And seeing the class of iris is data dot frame. That sort of establishes the frame of reference for ggplot, whereas all of these base plot functions, they don't really care. They just take whatever vector of random numbers you give them, and if they don't have exactly the same length, it'll give you an error. If one of these has 27 elements and one has 28 elements, it'll say, error, this doesn't work. And just remove the first one and see what it does. Yeah. X and Y lengths differ. Whereas yeah.
Sorry. No, I was just curious for what you just said about plot. If you have two vectors and one of the vectors has like the NaN, not a number, what does it do with that? Does it give it an error?
It'll skip it.
Oh, okay.
Yeah, they're both plotting functions are smart enough that if there's an NA, they don't plot that point. So if you've got an X value, but the Y value is NA, it won't get plotted under either of these.
Okay, cool.
Okay. I talked about adding points to a plot. One of the great strengths of ggplot, and this is where I give it a ton of credit, is facets. So facets, I've also heard called small multiples, but it's basically a way of making the same plot in slightly different ways multiple times. And so we saw a plot earlier that was basically this, where we've got temperature versus relative humidity, and the color was based on region, east versus west. But here, we actually do a facet wrap by region. We're still coloring by region as well, so that's why these are different colors. But we're doing a facet wrap by region, and we're saying number of rows equals 1, meaning we want these on the same row. So that means side by side. We could also have said n col, number of columns, equals 1, in which case these would be one on top of the other. But this is a really great way of showing sort of different angles of the same data set, basically. Making multiple plots side by side like this that share an axis, it's totally doable in baseplot, but it's actually a similar amount of code. And so I think this is a really clean way of handling it. And it allows you to see a lot more than you could before, right? Because before, these plots were mixed in, these points were mixed together. And so it was a little hard to see, like, oh, there's actually a lot more variation in the humidity on the west than the east. And so, yeah, this is a really big strength, is the ability to facet by categorical variables.
Can you explain that line 1 of code there?
This line,
Yeah.
oh God, yeah, they use the pipe. Okay. The pipe is another non-standard thing, although it's actually recently become standard. The pipe is a way of basically saying whatever happens on this line, use it as the input for the next line. So rather than saying ggplot parentheses data equals blah, 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 it's taking this data set and piping it into the ggplot function. And so automatically that gets interpreted as the first argument, which is data. The subsetting here, we saw this yesterday. The subsetting is just to remove any points where the region is NA. So some of these points have missing region information. So we're subsetting down to the ones where, you know, the region variable is not missing, and then piping that into the ggplot function. If you try to use this pipe symbol, it won't work, because this pipe symbol comes from the Magritter package. You can install the Magritter package and then load it the same way we did with ggplot2, and then you'll have access to it. Or you can use the built-in pipe, which looks like vertical bar greater than. And so if I do that and then get rid of this, we'll functionally be doing the same thing. So this is the built-in pipe symbol, and it does the same thing as this. But it's very non-standard. Like, again, this is one of the reasons that I don't like ggplot, is that it's basically a completely different programming language. There's a lot of peculiarities like this that only exist for the tidyverse and ggplot, but don't exist for base R. And for a long time, the pipe was one of those, but now we've recently added a pipe in base R. But like this plus symbol is not doing addition. Same thing. I don't like this construction, so I'm going to go back to data equals iris. I think that's more interpretable from a human standpoint. You can also facet on multiple variables. So here it's region versus whether it's high or low elevation. So we had 2 categorical variables here. We've only got the 1 categorical variable in our iris data set, so I won't demonstrate this. But it's just, you can see how quickly this could potentially multiply into lots and lots and lots of plots if you had multiple categorical variables. And ggplot is just very good at handling that. It's very nice. Yeah, this is how I would do it in base R. And as you can see, it's a little bit of a mess. We'll talk a little bit. Yeah, we've got a little bit of time. Okay. So you can also add additional elements. A common one is a smoothing line. That's not a very good, yeah, here's a good representation of that. So geom smooth, if you're familiar with low S regression, it's basically a low S regression. And it's predicting Y as a function of X, and it's allowing it to fit sort of a smooth curve to that relationship. And there are functions in R for doing low S regression, and then there's plotting functions for adding a line to a plot. But if you don't actually care about the statistics of the smoothing function, you just want to show it on a plot for visualization purposes, this is a very quick and easy way to add a trend line basically to a plot. And so here it's split by region again, but we can see we've got a trend line for temperature versus relative humidity for both the east and west regions. Super easy, like 2 lines of code, quick, clean. I wish it showed the actual data, but we could do that. ggplot can also do histograms the same way that we can do histograms in base R. I don't love this because there's no separation between the bars, but it gives you a sense for the overall shape of the distribution. Box plots in ggplot look like this. Again, the benefit of a built-in legend is pretty useful. Lines, here we go. Here's a line plot. If you want to do geom line, it's very much the same as the lines function in base R. And then something that something that ggplot can do quite well if you load additional packages that include, data about maps, is make maps. And so here's a map of the world made with ggplot. Notice it relies on this function map data, and that comes from an external package called maps. So in order to get this code to work, you would need to do like we did before, install.packages maps and library maps. Somebody asked earlier about how often you need to do library ggplot and library maps. And you need to do those every new R session, every time you start a new session. However, you only need to install a package once. So once I've installed the maps package, I can just get rid of that code. I don't need it anymore. I'll just have to reload the maps package the next time I start an R session. If you ever update your R, so notice I'm a couple of versions behind. 4.4.1 is the current R version. When you update your R version, you will need to reinstall packages. So here's a map. You could do a lot of interesting stuff with this. Here, they're just saying fill equals dark gray, but we could say fill equals, some categorical variable. So say we had data on all the countries and we wanted to color them by, what continent they're on or something like that. We could do that here. And then color equals white is just specifying the outline color. Yeah. So here's a map of the US colored by state. Just every state got a different color. One thing that I do want to mention real quick is notice how terrible this map looks because it's squished. The thing that is missing here, the thing that is wrong with this picture is the aspect ratio. And so in both ggplot and R, the plotting window is going to adjust to the data, and it's going to stretch the data to fit the plotting window. And so you'll always get the minimum X value on the far left, the maximum X value on the far right, the minimum Y value on the bottom, and the maximum Y value on the top. And sometimes that leads to weirdly distorted figures like this. And what you want to do in those cases is set the aspect ratio to 1, meaning, the ratio of units on the y-axis to units on the x-axis should be 1 to 1. I think our petal length and petal width was a good example of that. Yeah. If we just plot it in the default way, you can see that petal length goes from 1 to 7, whereas petal width goes from 0.5 to 2.5. So in some sense, if we wanted a more honest representation of that data, we would set ASP equals 1, that's aspect ratio. And then we end up with this plot, which shows there's really not as much variation in petal width as there is in petal length. There's a similar argument for doing that in ggplot, but I don't know it off the top of my head. Okay, and finally, just like there was a super handy reference sheet for base R commands, there's an extremely handy reference sheet for ggplot. And so I'm actually just gonna open this in another window so that you can see. Oh, don't look at my bookmarks, anybody. I'm just gonna Google it. RStudio cheat sheets. Yeah, posit cheat sheets. After they load, yeah. There's a whole collection of really great cheat sheets that can teach you how to do a lot of different things. And one of them should be ggplot2. There it is. Just click on the PDF. And here you go. Here's a really handy, extremely condensed introduction to a lot of the different things you can do with ggplot, including all the different types of plots that you can make. All right, and that's all the content that I wanted to cover today. So we're actually done on time. I'm happy to stick around and answer questions if anybody has them, but thanks for joining day 2, and we'll be back tomorrow with day 3 on data wrangling and high performance computing. Cool. Thanks, everybody.